Good morning, Year 5s. It is Tuesday and it is time for our maths. Hello. So, let's have a look at this. Do now first and then we'll have a chat about solving time problems. So, 79 times 1,000, we should know these by now, let's be honest. 3 zeros. 56 divided by 10, so 5.6. I'm not going to talk through them now. We should know how we're doing this. 0.33 times 1,000 should be 1, 2, 3. Oh, I just said I wasn't going to talk through it. Nearest 10 for 6,895. So there's our 10s, there's our 1s. The 5 you round up, so you round up the 9 to a 0, which means you affect the next number. Okay? Because 95, you round up to the next 10. That is also the next 100. So it becomes that. Okay. Nearest 100. Let's have a look at our hundreds. That's your hundreds. Have a look at the number before. And the 10s are 9, so you round that up. So that goes to a 9. 6,900 as well. Estimate these. 89 times 37. Let's make that 90. Let's make that one 40. 9 times 4 is 36, 2 zeros, roughly that. We could do 7,000 times 3 here, couldn't we? 7,000 times 3. So 740, oh, get rid of the zeros, 714, 21, put the zeros back on, 21,000. These ones here, so don't forget we're converting. We've got 0.4 kilometres. Now, this is, remember one thing, you've got to remember how many metres are in a kilometre. The way I always remember it is Usain Bolt. It's definitely not 10. It can't be 100 because Usain Bolt did not run a kilometre in 9.6, whatever it was. He only ran 100 metres. So it must be 1,000, which means you need to do something with this, where you either move your decimal this way or this way. If you move it this way, it makes 0.0004 metres. Well, that's not right because meters, there's more metres in a kilometre. So if you do it the other way, 1, 2, 3, it makes 400. Bit of maths common sense. 12 centimetres into millimetres. Well, there are 10 millimetres in a centimetre. So is it going to be 1.2 millimetres? Or 120 millimetres. It's going to be 120, isn't it? Okay, because there's lots more millimetres in centimetres. 0.11 as a percentage, that's 11%. 90% as a decimal, 0.9. And then another one, another equivalent fraction. Just keeping this really simple at the moment. Just reminding ourselves with halves. That's going to be 5/10. Lovely, excellent. On to our maths for today. So hopefully you did well with your Roman numerals. Love a bit of Roman numerals. Also, love a bit of time. So, we're going to be looking at time this week now. Too big, there we go. We're going to be looking at time questions. And in year 5, it goes straight to word of problems and working out timetables. So Wednesday and Thursday are bus and train timetables. Watch the video for those. I'm going to show you how to actually physically use them. I've used real ones. So today is just practicing our skill of solving time problems, understanding what the question's asking you, and an approach. Some of us can probably do this in our head, but some of us might need to jot something down. Okay, so I'm going to go through the first few. If I go through them all, the video will be about half an hour. Okay, but I will talk about the challenges. I'll talk about each question, but I'll only go through some of the answers. Okay, so first one. Ellie takes the train to Edinburgh. She sets off at 9:25 and she arrives at 11:47. How long was her journey? So you've just got to find how long it is from 9:25 to 11:47. So here's what some people start doing when they come across a time question. There we go. Now, you cannot solve a time question with column method, mainly because it requires pace value and a pattern base 10 numbers. You know, our number system orientates itself around 10, 100,000. There aren't ones, tens, and hundreds in this. First of all, even if you thought this was 9.25, that's not like, that's 9 whole hours, yes, but it's made up of 60 minutes, not 100. So the number, it does not work. You cannot do this, okay? So never do that for time. If you do need to jot things down, what I suggest doing, and we're rolling back the years to key stage 1 now, but it works. Number line. So we need to get from that time to that time. First thing I would do is the hours. Now you can go under or over here. I'm going to go over because that's standard practice, but I don't think I've given myself enough room. So you can easily do the hours first. So get to 11:25. Well, that's 2 hours straight there. Okay. And then we can add loads of tens. We need to get to 47. 25, 35, 45. Ah, there you go. 25, 35, 45. So 35, 45. So 35, 45. So that is adding, that's added 10, 20. That's added 20 minutes. Okay. And then I only need 2 to get to 47. So add 2. Goodness gracious. Mr. Cooper must have gone to Hogwarts because this is magic. Here's my answer. 2 hours, 22. Amazing. Now, let's be honest. A lot of us can probably do that in our heads. Yeah, but that's the mental calculation you should be doing. 2 hours, 22. Okay, but if you can't, and to be fair, when sometimes they're really far apart, or they cross over the hours, this might be useful. And I think most of us will find the ones where they go over the hours, the tricky ones. So like where the minutes complete another hour. So the first one was 2 hours 22. The next question. Ben travels on a coach to Manchester. His coach sets off at 8:19. So not quite 20 past 8. The journey is 1 hour 23. What time does he arrive? So you can do the same. You cannot just add 1 hour 23 underneath. Okay. Oh, actually, probably. Weirdly, you could with this one. Ooh, I'm not going to do. Ooh, I'm not going to do that. Hour 23. So add an hour. That's going to be 9:19. You can add 20. Add 20 minutes. So 19, 29, 39. What was it? An hour and 23. And then add 3, 39, 40, 41, 42. What time did he arrive? 9:42. There you go. The next one. Annabelle drives to Cardiff. Her journey takes 2 hours and 41 minutes. She arrives at 11:55. What time did she set off? So you want to be at the other end here. That's your finishing time. Okay, you're going to work backwards here. So her journey takes 2 hours and 41. Let's take the hours off first. I like working with the hours first. Take 2 hours. Oh, actually, if we're being really proper about this, I like to take away underneath. Take away 2 hours. So that makes 9:55. And take off 41. Now you can, to be fair, you can do 55 take away 41. You can do that here. Because they're just minutes. They're all right. There you go. It's 14. So it's 2 hours 14. So you know, use your brain. If you can take away minutes from each other, that's fine. But that's only okay because it doesn't go over another hour. Okay. So if that took us into another hour, that wouldn't work. So that's a bit naughty me doing that. So there you go. So that should be 9:14. Be that one. So that is an approach to your time problems. Okay. Now there might be a couple of you who are sorry, I'm looking at the table there. There might be a couple of you who are looking at this going, "Oh, I'm in year 5 and I still can't. I'm not great with my telling the time. I'm not great with my analog, or I'm not really. I don't really fully get the 24 hours." Well, for the word of problems, that's not too much of a issue, because it's all about, well, there are some 24-hour ones there, so don't forget 24-hour is the next 12. So after the first 12, 1 o'clock in the afternoon is then 13, because there are 24 hours in the day. If you need to have a chat with somebody at home, feel free. I mean, everyone at home, it's not like some of the things we've been doing in Angles where people might have forgotten about it. It's telling the time. We all do this. So you can always have a little chat with them. But the line method is what you would be doing in your head if you can't quite get there yet. So go through the questions. They do get a bit harder, but to be fair, they only get harder because the questions are longer. They're just like any worded problem. Think about what the most important thing is. So this one here, climbs up Totley Mountain. Climb takes 3 hours 33. He then spends 20 minutes at the top. After this, he climbs down the mountain again, which takes him an hour and 41. Obviously, it's downhill, it's quicker. If he arrives at the bottom of the mountain at 16:35, what time did he start? Well, he starts 16:35, take an hour and 41, take 20 minutes, take 3 hours, take 33 minutes. It's longer, but it's not, the approach isn't different, okay? So you've just got extra little bits. I'm going to go down to the challenge and explain to you the challenges. You probably recognise these because we have done time recently. So we have looked at 12 and 24-hour clocks. So just some word of problems. So theatre production finished at 21:15. The play lasted 2 hours 15. Answering 24 hours. It's these ones here. So this one, Sydney in Australia. This one's quite tricky. Sydney, Australia is 9 hours ahead of London. Dubai is 3 hours ahead of Turkey. Dubai is 3 hours ahead and Turkey is 2 hours ahead. New York is 5 hours behind and Rio de Janeiro is 4 hours behind London. Using a 24-hour clock system, state what the time is in each of these cities or countries when it is 7 in the morning in London, 4 in the afternoon and 6 in the evening. So you're going to make a list. So when it's 7 o'clock in the morning in London, Sydney is 9 hours ahead. So what time would it be there? Dubai is 3 hours ahead. So when it's 7 o'clock, when is it there? Turkey is 2 hours ahead. But New York is 5 behind. So what's 5 hours behind 7 o'clock? So you just need a list. 7 o'clock in London, 4 o'clock in London, 6 o'clock in London with the 24-hour. Okay? So it's quite a lot of questions here. I think this might take you potentially 15, 20 minutes, a bit longer perhaps, depending how we're doing with our time thing. So quite a hefty amount of maths this morning. But I think that's fine. It's Tuesday. We've got this in our English. So enjoy. Get cracking with these guys.